It is section 8.9, probability. We'll begin with the definition of random variable. A random variable is a function x that assigns a numeric value to each outcome. Once the random variable takes only finitely many values, then it is called a discrete random variable. Once it can take values in an entire interval, then it is a continuous random variable. Here, we define probability density function, PDF, for continuous random variable. That is a function f defined over the entire line and having these three properties. It must be piecewise continuous. It must be continuous except possibly at a finite number of points. And the f must be non-negative, and the integral over the entire line must be 1. That is the same as the whole summation of a possibility is 1. Okay, here, if x is a continuous random variable with the PDF f, then the probability that x is between C and D can be found through this integral C to D of f of x, the PDF. Now we can denote the probability in this way. Probability, now x has a value between C and D. Okay, let's see this example. The function f is given in this way. Now we want to verify that f is a PDF, probability density function. Okay, for part A, now in order for the function to be a PDF, first of all, it must be piecewise continuous, so that we first check the continuity. Now, the function is continuous on the left-hand side, completely 0, and right side is exponentially decaying. Of course, this is continuous, so that is piecewise continuous. Okay, now this is okay. And secondly, the function must be non-negative, and apparently now left-hand side is 0 and right-hand side all is positive, so then it's okay. Now integration of the function over whole line must be 1. Okay, let's check it. Integral minus infinity to infinity and ft and here dt. Okay, that one. In the left-hand side, the value is 0, so it can be written in this way, from 0 to infinity, ignoring the left side. And now f of t is 2 e to the minus 2t. Okay, so is antiderivative is minus e to the minus 2t. So we are evaluating from 0 to infinity. Now, once it's infinity, then it's 0. And once it's 1, then this is minus 1. So that here the value is 1. Okay. So these three conditions are satisfied so that it is a PDF. Okay. Now, the time t in hours and until a car passes a spot on a remote road is described by this PDF. Okay. Find the probability, so that probability where t is bounded by 1, less than or equal to 1. Okay, that is representing a hitchhiker at that spot we'll see a car within an hour. Okay, so we have to compute this one. Okay, that is, now the probability is integration from, in fact, minus infinity to 1. Okay, now f of t of dt. Okay, now again, from minus infinity to 0, it is 0, so that it can be written in this way from 0 to 1, and right side the value is 2 and e to the minus 2t and dt. Okay, so yes, antiderivative is minus 2 e to the minus 2t, and we are evaluating from 0 to 1. Okay, now it's 1. Okay, here we put here 2, and now along with this negation, we first evaluate along with the 0, that's 1, and then it's 1, then e to the minus 2. Okay, so that's the final answer. Okay, that is probability that a hitchhiker at that spot will see a car within 1 hour. Okay. Here, exponentially decreasing distribution, it has this form. Here, on exponentially decreasing probability density function is a PDF of the form. For arbitrary c positive, now c times e to the minus cx on the right side, and for the left hand side, the value is 0. That is exponentially decreasing PDF. Okay. Now, here we define expected value and mean. Sometimes it's called expected value, sometimes it's called mean of a continuous random variable with PDF f as the number obtained through that integration. An overall interval, here x times f of x, we try to find the mean of the x value so that an x value and probability is multiplied and summed. That is here a mean value or expected value of the random variable. Okay, here once now exponentially decaying PDF is given in this way, then for this one, let's try to find the mean of the random variable. Okay. So in definition, mean is mu, that is same as integral minus infinity to infinity, and x times f of x dx. Right? That is the definition. So we have to compute this one. Now in negative, the value is 0, so we can write this one from 0 to infinity, and x times, now c, f of x is practical here, c times e to the minus cx, now dx. Right? Okay, here we can compute this one by using integration by part. Let's rewrite this one in this way. That is, c can go out, and then from 0 to infinity, and there's xn e to the minus cx and dx. Okay. And here, for integration by parts, now c is here. Okay, now, and okay, if we consider that is u and that is now v prime, then here ux and b prime is, okay, minus 1 over c, minus 1 over c. Okay, okay. Let's rewrite here. Okay, minus 1 over c, and then e to the minus cx, right? And then we have to evaluate from here 0 to infinity, and then minus. Okay. Now, derivative of this one and that one. So that is same as, now along with this negation, that is here 1 over c, and then here integral, and e to the minus cx and dx. Okay, that's now, okay, that is here from 0 to infinity. Okay, for this one, now, okay, that is, okay, in fact, if you try to get integral along with the c, then the value is 1, so that it will be 1 over c, so that the value must be 1 over c. So here we have this one. Now that is now c, and then evaluation from 0 to infinity. Once it's infinity, that term is 0. And of course here now x goes to infinity. However, this one approaches 0 much faster, so that this multiplication will be 0. And once x is 0, then this value is around is 1. Now this is 0. So it is 0. So there, for the first term is 0. And for the second one, that is 1 over c squared. So that eventually the mean value is 1 over c. Okay. For general arbitrary c positive, here mean of this random variable and with the PDF is 1 over c. So here we can write down in this way. If we try to indicate the mean, then f of x for exponentially decaying probability density function, we can write in this way. Rather than c, just we try to use 1 over mu, because now the c is 1 over mu, so that we can write in this way. Here, 1 over mu and minus x over mu. Then, along with this one, we can see easily the mean is mu. Okay. Now, also we can measure the centrality of a random variable with a median rather than mean. The median is the center of the whole the events, so that here and m, the median is defined in this way, from minus infinity to m of the PDF is half, and then automatically m to infinity must be half. Either one can be used to find the m. Okay, that is called the median, the center of the whole events. Okay, it's different from mean. Okay. Okay. So find the median of a random variable x with the exponential PDF. So from this one, now if we try to get here, try to put m, so that from 0 to m, f of x dx is half. Then its antiderivative is now this one, and from 0 to m, we can get here 1 minus e to the minus cm. Or you may use this one from m to infinity. Now its antiderivative is the same, minus e to the minus cx. And now evaluations from m to infinity. Once infinity, then it is 0. And once it's m, then here there is e to the minus cm. Okay, so we have to solve that. This is half, right? So we have to solve this one. So the taking logarithm, and then so that minus cm is the same as now logarithm of a half. So along with this negation, it changes into logarithm 2. So that here m is 1 over c and logarithm 2. Of course, 1 over c is mu, so that we can write down here mu logarithm 2. That is now the median. Logarithm 2 is here less than 1, so that median is smaller than the mean for every here the exponential random variable. Okay. A manufacturer of light bulb finds that the mean lifetime of a bulb is 1200 hours. Assume the life of a bulb is exponentially distributed. Find the probability that a bulb will last less than is guaranteed lifetime of 1,000 hours. That means that here we have to get, and in the beginning, here f of t, so that mu, that mean is given, there's 1 over mu, so that here 1 over 1200, and e to the minus t over 1200. That is the PDF. So that once we have to get probability such that the lifetime is here less than 1,000, then here for part A, here the probability is basically integral from 0 to 1,000 of the probability density function. There's 1 over 1200 and e to the minus t over 1200 and dt. Right? So its antiderivative is same as minus e to the minus t over 1200. Now we are evaluating from 0 to 1000. Okay. So yeah, that is now once it is 0, then it's 1. Now once it is 1000, that is 5 over 6. So that is e to the minus 5 over 6. Okay, so that's the answer for part A. Part B, in a batch of light bulb, what is the expected time until and half the light bulb in the batch fail, which means that is we have to find the median. Okay, median. So here to find the median, one may use either one of these equations. So that now also we know from this one that the same as mu times logarithm 2. So that if we are using the formula, then here median is same as mu and logarithm 2. What is mu? Already given here 1200. And here logarithm 2. So that is exactly the median. Okay? You can finish it this way. Okay, the mean waiting time to get served after walking into a bakery is 30 seconds. Then immediately you may think the if we assume that the exponential density function, then now f of t on positive can be written here. 30 is mean, so that 1 over 30 e to the minus t over 30. That is the corresponding PDF. What is the probability a customer waits 15 seconds or less? Okay, now the probability is from here 0 to 15. The upper bound is 15 of f of t. Here 1 over 30 and e to the minus t over 30 and dt. Okay, antiderivative is e to the minus e to the minus t over 30, and we are evaluating from 0 to 15. Once it is 0, then 1. Once it's 15, then that makes half, so that e to the minus 1/2, right? So that is probability. Okay, here numeric value is about 0.393. What is the probability a customer waits longer than 1 minute? That means that here, and you have to integrate from 1 minute, that is a 60th second, and up to infinity, right? Of f of t and dt. Okay, for this one, again, antiderivative is given in this way, minus e to the minus t over 30, and we are evaluating from 60 to infinity. Okay, when it is 60, then that is e to the minus 2, and once it is infinity, then the value is 0. So that is the answer for part B. Okay, that is now we try to get, in fact, from whole and from 0 to 6 is subtracted, so that we have 1 minus e to the minus 2. But you can get in this way. Okay, what is the probability a customer waits exactly 5 minutes? That is 0, because 5 minutes is here 300 second. Now, so the integration must be done from 300 to 300. So interval length is 0. So the integral of the PDF will be 0, so that the probability is 0. Okay, you don't have to complete it. Just 300, from 300 to 300, it must be 0. Okay. If 200 customers comes to the bakery in a day, how many are likely to be served within 3 minutes? Okay. The probability that each customer, if we look at each customer, then the probability that each customer is served within 3 minutes, that is now time is 3 minutes, is now here computed by using from 0 to 180 second and of the PDF. Okay, so once you compute it, then that is now 0.997521. So it is a very high probability. Now here, so that anyway, for each person, such good probability. Now, we try to consider at least one customer is waiting longer than 3 minutes. Okay, that is for each person, that one. So that if all 200 the customers are served within 3 minutes, then the probability is basically this one, right? And a single person is served within 3 minutes, along with that probability, and second one, third one, and so on. So that for all 200 people are served within 3 minutes is basically this probability. At least one customer waits longer than 3 minutes is now from 1, and now subtract this quantity. If you measure this numeric value, then it is about 0.39. That means that most likely all 200 would be served within 3 minutes. Okay. So here, the answer is this one. Okay, this is end of the part 1, and we'll continue in the second part. Thank you.